Hello again. This is the very interesting lesson I was talking about. We are going to dissect the words and or when it comes to graphing on a number line. So if you had the word and something said x is greater than 2 and x is less than 6, you would look at a number line and you would go to 6 and you would make an open circle with an arrow to the left. So I just graphed this. And then you would go to 2 and you would make an open circle and x is greater than with an arrow to the right. And you would connect them because the word and means both things are true. So the place that both of these are true is from 2 to 6, not including 2 or 6. So I'm going to show these in two different colors, and maybe it might make a little more sense. The word and is where both the green and the blue show up. So even though the blue continues forever this way, and even though the green continues forever this way, they both show up right here. So in order to graph this, you don't graph any of that part or any of this part. You are only graphing what I initially had, which was from here to here with open circles. So I'm going to write x is less than 2 and x is greater than 6. So I flipped both inequalities. This is a totally different problem. This has the word and. So I'm going to make a number line. At 2 goes an open circle with an arrow to the left. At 6 goes an open circle with an arrow to the right. So looking at this inequality, where do the black and the blue overlap? Never. There's never a place where there is black and blue, where there's both of them overlapping. So this is no solution. Now, we're going to do the same exact thing with the word or. So, x is less than 2 or x is greater than 6. So it's the exact same problem. I'm doing a new number line. It's going to look the exact same. At 2, you have an open circle with an arrow to the left. And at 6, you have a open circle and open circle with an arrow to the right. So that is the solution for or. Or means that it's black or it's blue or it's both. It says any of those are right because it's one or the other or both. So I'm going to write this again the same way of the very first time. X is greater than 2, then the word or, x is less than 6. So going back to the number line. At 2, you have an open circle with an arrow to the right. I'm just going to extend this forever. At 6, you have an open circle with an arrow to the left. Now, the first problem when this interesting video first started was the word and. And for and purposes, this is where both the blue and the green are. So for the very first problem, the answer was just the open circle from here to here because it said and. Well, this one says or. And or is where the blue or the green or both of them are. So blue or green or both is everywhere. So this is all solutions. And to show all solutions, you can literally darken both arrows and darken the number line, and you're shading every single thing. And I would probably write all solutions too because sometimes that's a little hard to see. So these are called compound inequalities. So I'm going to give you one to try. -4 plus a is greater than 1, or -4 plus a is less than -3. See what you can do. So you should have added 4. You would have a is greater than 5, the word or, and then over here you would have added 4, and you have a is less than 1. So then you make your exciting number line. You go to 5. You make an open circle with an arrow to the right. You go to 1. You make an open circle with an arrow to the left. That is your solution. Both of the open circles with the arrows in opposing directions. Now, if that word said and, it would be no solution. But the word says or, so that is your solution. We will do another. I'll just give you x is greater than 4 or x is greater than 0. See if you can graph that. So at 4, you're going to have an open circle with an arrow to the left. At 0, you are going to have an open circle with an arrow to the right. The word is or. So where is one or the other or both? It is all solutions. It is everywhere. This goes forever in this direction, and this goes forever in this direction. If that word said and, you would just be right here because that's where both of them are. But the word is or, and so that's all solutions because one or the other or both are everywhere. Okay, now there's another weird thing. Let's say you have a number line and things are going in both directions. So you have something here and you have something here. Now, if the word is and, you would just graph the black because where both of the colors are is where the black and above is. If the word said or, you would just graph the green because the green takes into consideration the green and the black. So you wouldn't even have to have the other arrow. So if the word says and, you literally erase the green part and just have that black part. I'm going to make another number line in the other direction. Take a second and think, if it says and, which color do you graph? You only graph one of them. And if it says or, which color do you graph? So hopefully you figured out that the word and is where one or is where both of them are. So the only place both colors are the blue and lower. The word or is where the black or the blue are. So you would graph just the black color. This is with the inequality on either side of the x. So this is actually two separate equations. You have this equation and you have this equation. So I'm just going to write them totally separate. So 4 is less than or equal to x plus 2. And then the other one is x plus 2 is less than or equal to 8. And then we'll just solve them and graph them both and see what works. So you're going to subtract 2. 2 is less than or equal to x. And you're going to want to rewrite that so that the x is on the left and the Pac-Man inequality still faces the same way towards the letter, so it's still eating the X. So on your number line, you're going to go to 2, and you're going to put a closed circle with an arrow to the right. And over here, you subtract 2. You get X is less than or equal to 6. So at 6, you would put a closed circle with an arrow to the left. So now we need to figure out if this solution is an and, which means that the only solution would be right here, or if it's an or, which means it would be all solutions. So we're going to test that by plugging in numbers and seeing if they work. So any number in here should work for sure, but we'll just plug it in to test because it's super fun too. So 3 plus 2 is 5. Is 4 less than or equal to 5 less than or equal to 8? Yes, that is true. So that is true, which this area again would be a solution whether this is an and or an or. So now let's test a number down here. So 0 is pretty easy to test. So 0 plus 2. Is 4 less than or equal to 2 less than or equal to 8? No. So that means this stuff is not a solution, which means that this stuff is most likely not a solution. But you can test just to make sure. So 10 plus 2 is 12, and you can test any number above 6. I'm just picking 10 because it seems easy. So is 4 less than or equal to 12 less than or equal to 8? Nope, this does not work, so that is not a solution. So the grand finale of this graph is 2 to 6 with closed circles like that. That's the solution for that inequality. Let's do the same exact thing with the inequalities facing the opposite direction. So 4 is greater than or equal to x plus 2 is greater than or equal to 8. Same thing, different direction. We've got this and we've got this. And when you write this problem initially, you can flip it right away and put x plus 2 is less than or equal to 4 if that calls you to do. All right, so isolate the x by subtracting the 2. We can go ahead and make the number line. And the 2 is right here. You have a closed circle with an arrow to the left. This one's going to be 6. And you have a closed circle with an arrow to the left. I mean, that's right. The arrow is to the right, just like I drew. Your other right. The right. Okay, so this most likely should be the solution. We just have to make sure that this wasn't an and problem, because if it is an and problem, then it's actually no solution. So we're going to test a number down here, which should work. So 0 plus 2, according to our graph, it should work. Is 4 greater than or equal to 2 greater than or equal to 8? So that is no. So this stuff does not work. That part does not work. Up here, if you test a 10, it should not work. So 12 is, because 10 plus 2 is 4 greater than or equal to 12. That does not work. So even though we get this lovely graph, this is meant to be an and statement. And when you get opposing lines, it's actually no solution. So it's really imperative when you have compound inequalities written like this, where you break them up, that you are able to test the solutions after you have graphed them to see if they are meant to be an and or an or. Okay, so we're going to do another problem both ways. I'm going to have you try it, and then we'll go over it, and then we will call it a day. So we're going to do one like that and then the exact same one with the inequalities flipped. So go ahead and hit pause. All right, just a recap, you have two completely different equations, this and this. So -5 is less than or equal to 2x plus 3 is one of the equations. 2x plus 3 is greater than 9 is the other equation. So I'm going to rewrite the blue side initially. The Pac-Man is still eating the 2x plus 3. You're going to bring the numbers together so they can be 1. They are the number -8. And then you're going to divide by 2. So x is alone. X is greater than or equal to -4. You only flip the inequality when you're multiplying or dividing by a negative. Just to recap. So we don't really know if our other number is going to be above or below -4. So just put -4 in the middle-ish. You have a closed circle with an arrow to the right because it reads is greater than. Over here in the Greenland, you are going to subtract 3. So 2x is greater than 6. When you divide by 2 to isolate the x to make it oh so happy, you get a 3. 3 is up here. You have an open circle with an arrow to the right. So we need to figure out if the blue is the proper graph or if the green is the proper graph. We need to figure out, do these answers work or do just these answers work? So we need to test a number in between -4 and 3. 0 pops out at me as being easy to plug in. You could choose whatever number is calling you. So -5 is less than or equal to 2 times 0 plus 3 is 3. So -5 is less than or equal to 3. That's true. And then is 3 greater than 9? That's true. So this is good. This works. In here works. So most likely up here is going to work too. But let's just check. 10 to me, that is calling me. Any number over 3 you can plug in. So if you plug in 10, you have 2 times 10 plus 3. Well, that's 23. So -5 is less than or equal to 23. That is true. And then is 23 greater than 9? That is true. So your graph to this equation is actually the blue graph. This is an or statement because the blue is the one that works. One or the other or both. Okay, we're going to graph the same one, opposite directions. We've got this, we've got this. So -5 is greater than or equal to 2x plus 3. You may just want to rewrite that inequality instantly with the Pac-Man eating the -5. And then the 2x plus 3 is greater than 9. So wait a second. Yeah. So subtract 3, 2x is less than 6. Divide by 2, x is less than 3. On the number line, you're going to go to 3, put an open circle with an arrow to the left. And the blue, you're going to subtract 3 and then divide by 2. So x is less than or equal to -4. At -4, you put a closed circle with an arrow to the left. So we are either going to graph just the green or the blue. So we need to plug in a number between here. Again, 0 is lovely. So when you plug 0 in, again, you get 3. So is -5 greater than or equal to 3? No. So already this does not work. So that means a number up here should work. Do you want to just plug in -5 It doesn't really matter. You could plug in negative 10. So 2 times negative 5 plus 3 is negative 10 plus 3, which is negative 7. So we have, is negative 5 greater than or equal to negative 7? Yes, that's true. And is negative 7 less than 9? I'm just finishing this inequality up here. Yes, that is true. So this situation, just the blue, is what you're going to graph. So the grand finale of this graph is negative 4 and below. And so this situation is an and situation. And the easiest way is really just to plug it in and make it make sense. It's really hard to memorize which way the Pac-Mans go compared to the size of the numbers means what. So I hope that was as interesting as you thought it would be. Have a beautiful night. We will master this tomorrow. There's more work with Algebra Nation. If you want right now, you could go to section, chapter, topic, whatever that is, 2.8 in Algebra Nation, and you could try that out, or we'll be doing that most likely tomorrow. Enjoy your night with mathematics.